Welcome to all. So myself, SNBP Raviteja. I am the Assistant Professor of ECE Department, ECE Institute of Technology, Engineering, Tadipalligudem. So today I would like to give a brief introduction about the feedback amplifiers. So coming to this feedback amplifiers, I am going to cover the following contents. One is the basic introduction of feedback, types of feedbacks, so what is the advantage of negative feedback system? So these are the topics I am going to cover for this lecture. So coming to the first one, what is meant by feedback? So before going to this topic, first of all, the basic block diagram of an amplifier that is given as, here this is our generalized amplifier. So for every amplifier, so we have input source and we have to collect output from an amplifier. So from this, what is meant by feedback here? So coming to feedback, our first topic is feedback. What is meant by feedback? The feedback is nothing but the output of the amplifier. That means the fractional output of the amplifier signal that should be connected with a feedback mechanism to the input of an amplifier. So this is simply called feedback. This is simply called feedback here. So this is called feedback. That means what is meant by feedback? That means the feedback is nothing but it is a fractional output or the output signal of a generalized amplifier or a conventional amplifier that is fed to the input of this amplifier input signal. So then this is said to be a feedback. So coming to the amplifier concepts, what is meant by feedback amplifier? What is meant by feedback amplifier? So this is our generalized amplifier. So according to my definition, the feedback is nothing but it is a fractional signal of the output of an amplifier that is fed to the input of this amplifier. Then it is said to be a feedback amplifier. So during this feedback section, so we have a feedback factor or a feedback ratio that is given by beta. So everybody, please all of you observe the diagram. Here we have a feedback network. So this is called as feedback. This is called feedback factor, which is labeled by beta here. And now, so the amplifier, the gain, we call it as A. So this is amplifier A here, that is the gain of the amplifier A, capital A, and the feedback network which is given as the ratio called beta network. So this is called a beta. That means the connection which is fed from the amplifier output to the connection of this amplifier which is connected to the feedback input here. That means the output of the amplifier mean called the conventional output of the amplifier which is fed to the input of the feedback network, and the output of the feedback that should be given as input of the amplifier here. So means now the feedback output input which is given as the second output here, and now the generalized first input which is collected from the external source. That means the feedback amplifier consisting of how many inputs here? 2 inputs. That means the first input which is collected from the input source of an amplifier, this is the external source, and the second output or the second input of the amplifier which is fed from the feedback network. So these two are the inputs which are fed to the feedback amplifier. So based on this 2 inputs, one is from external source input and another one is collected from the feedback ratio. So this is the second input. So by the help of these 2 inputs, our amplifier which can be given as a resultant of output signal, so then this is called feedback amplifier. See, please all of you observe the block diagram of the feedback amplifier consisting of one is input source here, generalized conventional amplifier with a gain of capital A, and the beta network which is the ratio of beta, that means output signal by input signal. So this is the feedback network. So based on this block diagram, so we simply call it as, this is called feedback amplifier. This is our first one. Under the first one, what we are going to discuss according to our contents, the first one is what is meant by feedback, second one is classification. So coming to the second one, so we are going to discussing about the classification. Our second content is classification of feedback amplifiers. So the classification which is basically depends on the resultant of the output signal which is fed from the amplifier output to the input of the amplifier. So please all of you observe carefully how the classification will be done. That means here this is our generalized amplifier diagram with a gain of capital A here, and now this is our external source. This is called input source. Now this input source is directly connected to the amplifier, conventional amplifier, and the conventional amplifier which is producing an output. This is output signal. According to the feedback concept, what we are going to introduce, that means we are going to introduce the another block which is called feedback with a factor of beta. Now this output which is directly connected here, and now this output of feedback that should be given as the resultant of this amplifier input again. So now here we have one device. So this is called mixer. This is called mixer. So here the mixer consisting of, there are two inputs which are fed from the, one is input source of the signal and another one is the feedback network signal, first signal and second signal. By the help of first and second signal, whenever we are going to apply any two different signals, then the resultant will be generated in the form of two forms. One is either it may be addition or subtraction. So here there are two outputs we expect from the resultant of this mixer signal. So one is adder signal, second one is subtracting signal. So coming to the input source, just I simply labeled as, here we call it as Vs here. The input of the amplifier I simply assumed as Vi here, and the output which is given as V0 here, and the feedback signal we simply call it as a feedback voltage Vf. So according to these notations, so let us discuss in detail the classification of the feedback amplifiers. So those are basically two types. One is positive feedback. Second one is negative feedback. How the positive feedback will be happened in our feedback amplifiers. That means according to this diagram, here there are two resultants we can expect from the mixer. One is adder network and second one is subtracting output. So let us assume adder. So for example, addition of two components, that means the input signal Vi which is given as Vs plus Vf. Suppose if you are going to assume Vi is equivalence of Vs plus feedback signal is Vf. So this is one component. This is called addition. This is called addition. That means the addition is given as the resultant of this mixer, that is given as Vi is equivalence of Vs plus Vf. So what is our second one? Subtraction signal. Subtraction signal means the input of this amplifier that should be depends on subtraction, so that the subtraction which is given as Vs minus Vf. This is called subtraction. So there are two signals which can be able to produce with the help of this common mixer signal. That means the Vi is equivalence of Vs minus Vf, and the second one is Vi is equivalence of Vs plus Vf. So there are two signals. Those two are given as the classification. For example, if the input signal which is equivalence of the addition of two signals like Vs plus Vf, then this type of feedback amplifier is said to be a positive feedback amplifier. Whenever the input signal which is given as a different signal or subtracted signal from the input source with respect to feedback signal, that is Vs minus Vf, is nothing but this is called negative feedback signal, or mean called negative feedback amplifier. Positive feedback amplifier and negative feedback amplifier. That means the positive feedback which is given as the resultant of the input signal of the amplifier which is given as the feedback signal added with the external input source signal. That means Vi is equivalence of Vs plus Vf, then we said to be it is the addition. So then this type of feedback amplifier is nothing but positive feedback amplifier. So coming to second case, whenever the input signal is given as the subtraction of the feedback signal called Vf is subtracted from the input source, that is called Vs minus Vf, then it is said to be a negative feedback amplifier. So these are the classifications of feedback amplifiers. And coming to the feedback amplifiers, so here we are going to assume addition and subtraction. There are two methods we are going to assume here. So for example, if the addition is possible, then what is the resultant of the feedback amplifier? Suppose if the feedback is or feedback amplifier is a negative feedback, so then what is the resultant of an amplifier? Let us see in detail according to the explanation. Please all of you listen carefully. So this is V0 here. Please all of you assume here the input signal is a sinusoidal signal with a phase angle of 0 degrees, and the same input, for example, if there is no any feedback here, just if you are going to directly given as the input of an amplifier, we call it as VI here. So after this amplifier, for every amplifier, there is a generation of 180 degrees of phase difference between output versus input signal. That means the output voltage which is given as here, the input is given as a Vs here. Now the output of this amplifier which is going to produce a 180 degrees of phase shift here. So now this is generating a 180 degrees of phase shifted signal with respect to the input signal. So now the same output will be given as this input of the feedback network. Now the same input which is fed from the output of the amplifier to the feedback input here, and now which is going to produce again one more 180 degrees. So here we are going to be simply take the shifting of the signal, that is again given as again one more 180 here. So that 180 degree of the signal that is given as like this form. So now if you are going to assume the input signal Vs and the feedback signal Vf both are in phase here. Please all of you look into this here. This is also starts from 0 here, and which is also start from 0 and which is ended at 360 degrees. That means both the signals are in phase. That means the positive feedback amplifier. That means here what we are going to do here, whenever the input voltage Vi is equivalence of Vs plus the input voltage Vi of an amplifier is given as Vs plus Vf. When that means whenever the both signals, one is feedback signal and external source input signal, both are in phase with each other, then we have to follow the condition Vi is equivalence of Vs plus Vf. So the previous discussion, what we conclude that for positive feedback amplifier, the input voltage, the difference of this mixer, that should be given as Vi is equivalence of Vs plus Vf. So by this consent, what happens here, the amplifier, the input is always at higher value, then our gain is also becomes always at a high level value. That means for positive feedback amplifiers, the gain of the amplifier that is always high. The positive feedback amplifiers, the gain is always high. So whenever the gain is always high, the bandwidth is always lower value. So these type of positive feedback amplifiers are mainly used at oscillators, multivibrators, oscillators and multivibrators. So these two are very frequently used feedback amplifier networks under oscillator and as well as multivibrator circuits. So this is the case one. Under the classification, the first case is positive feedback amplifier. That means what we conclude, that means here during the positive feedback amplifiers, the input source Vs and the feedback voltage Vf must be always addition. So now the resultant of Vi which is given as Vs plus Vf, that means always the input voltage always becomes higher. Then based on this, our gain is also becomes improved. Whenever the gain is becomes improved, then our bandwidth is becomes reduced. So both are inversely proportional to each other. So these type of feedback amplifiers are used at oscillators and as well as multivibrator circuits. So coming to the second case, negative feedback amplifier. So what we discussed earlier for negative feedback amplifiers, that means the input of the amplifier that is given as subtraction of the feedback voltage from external input signal. During a positive feedback, the resultant of Vf must be always in phase with our input signal. So during the positive feedback amplifiers, the Vs and Vf is always in phase. So coming to negative feedback amplifiers, what happens here? That means the input signal is as it is like a Vs and the Vf is always collected from the feedback network. So now the negative feedback amplifiers, the actual external input source is applied as a Vs here, and at the same time the amplifier gain is always capital A here with a conventional gain, and the phase shift is again 180 degrees of the phase shift, and based on this here you may generate this type of output waveform on amplifier. The same output will be given as the input of this feedback amplifier. So now during the feedback amplifier for negative feedbacks, the phase shift is always 0. There is no any phase shift here. So that means for negative feedback amplifiers, the feedback network or the beta ratio that should be given as the buffer network. So buffer network means whatever the input signal is you have to fed, that should be given as the output without any change, so that the same output will be given as the same signal will be given as a resultant of the output signal from the feedback network. So our output signal, which is given as the same one without any change of the input of the feedback. Suppose if you are going to observe these two signals, one is feedback signal and VS signal called external input signal. So the input source signal is at start from 0 and which is starts from 180 degrees. So now, so both are comparing with each other. So definitely these two are the out of phase. So whenever the out of phase signal is become generated, so definitely our input voltage of an amplifier VI is equivalence of Vs minus Vf. What happens here? The input signal is becomes decreased, so then our gain is also becomes decreased. Whenever the gain is becomes decreased for the second case called negative feedback, that means the gain is becomes decreased, the bandwidth is always improved. So this is the second case of the negative feedback amplifier. So based on the gain is becomes reduced, then this is can be able to possible under feedback networks. Feedback amplifiers, definitely we have to maintain the stability of the gain. So whenever the negative feedback is applied, so with the help of Vi is equivalence of Vs minus Vf, so according to the consent, whenever the input source signal and the feedback signal both are out of phase, then our resultant of the input signal from the mixer Vi is equivalence of Vs minus Vf, then our output voltage which is given as constant value. That means based on this constant output voltage, definitely our gain is becomes always constant, so then which is becomes reduced and the bandwidth is always increased. So whenever the bandwidth is increased, which can be able to allow more number of frequency components from the input band of the signal. So these type of amplifiers are basically used in our feedback amplifiers to stabilize the gain of the amplifier for stability purpose. For stability purpose, here we are going to be simply use our negative feedback amplifiers, and these type of negative feedback amplifiers are also used for controlling circuits. So this is the basic classification of feedback amplifiers. So let us discuss in detail. So here the classification of feedback amplifiers are mainly classified into two types. One is positive feedback amplifier. Second one is negative feedback amplifiers. So I discussed briefly in detail. Feedback amplifiers are mainly two types. One is positive feedback amplifier. Second one is negative feedback amplifiers. The positive feedback amplifier which can be able to produce, so whenever both the input signal called source signal and the feedback signal must be in phase with each other, then it is said to be positive feedback amplifier. The resultant of this positive feedback amplifier of input of this amplifier, that is Vi is equivalence of Vs plus Vf. Similarly for negative feedback amplifier, the Vs and Vf both are out of phase. Then the resultant of the input signal of an amplifier Vi is equivalence of subtraction of these two, Vs minus Vf. So this is the classification of feedback amplifiers. So finally the third content is nothing but advantage of negative feedback amplifiers. So basically we have various number of advantages coming to negative feedback amplifier, because the gain is become stabilized and the distortion is always less. That means the noise is very less. That is called harmonic distortion is very low. The gain is become stabilized. The bandwidth is always at higher value. So these are the various advantages when compared to positive feedback with respect to negative feedback. So this is the course lecture outcome. So this is our outlines. So basically in this lecture we are going to discussing about mainly three. So one is what is meant by feedback, what is meant by feedback amplifier, and second one is classification of the feedback amplifier, and based on this here what are the advantages of negative feedback amplifiers. So these are the contents which are going to be covered in this lecture.